Hi students, in this video we will discuss the questions of page number 200, 202, 209, 213, 216, 218 and 220 from chapter number 12, Electricity. First we will discuss questions of page number 200. These are the questions. First question, what does an electric circuit mean? A continuous closed path made of electric components through which an electric current flows is known as an electric circuit. A simple circuit consists of the following components. Okay, so a simple circuit we can draw like a conductor will be there, that means a wire, and one battery will be there and one switch will be there. Okay, current direction it will be from positive to negative direction. Okay, so this is a basic simple circuit and we can add any of these components to a circuit according to the requirements. Question number 2, define the unit of current. The unit of current, it is ampere. Okay, SI unit of current, it is ampere. Ampere we can define as it is the flow of 1 coulomb of charge per second. That means 1 ampere, okay, we can represent as 1 coulomb per 1 second. This is the meaning of 1 ampere. Question number 3. Calculate the number of electrons constituting 1 coulomb of charge. That means 1 electron, okay, possess 1.6 into 10 raised to minus 19 coulomb. Okay, one electron has a charge of 1.6 into 10 raised to minus 19. Our question is, one coulomb charge consists of how many electrons? Okay, so one coulomb charge consists of how many electrons? We will find like 1 by 1.6 into 10 raised to minus 19, that is equal to 6 into 10 raised to 18 electrons. Okay, so always it is better to by heart these numbers. 1 electron it is equal to 1.6 into 10 raised to minus 19 coulomb. 1 coulomb is equal to 6 into 10 raised to 18 electrons. Questions from page number 202. These are the questions. First question, name a device that helps to maintain potential difference across a conductor. That is cell or battery. Question number 2, what is mean by saying that the potential difference between 2 points is 1 volt? What is the meaning of that? When 1 joule of work is done to move a charge of 1 coulomb from one point to another, it is said that the potential difference between 2 points is 1 volt. And this is the formula for the potential difference V, W by Q, where W is the work done and Q is the charge. Question number 3, how much energy is given to each coulomb of charge passing through a 6-volt battery? So, we will use the previous formula for this. V is equal to W by Q. Okay, here V it's given, it is 6. Okay, they are asking how much energy. Energy it is equal to work done. Energy and work done both are equal. Okay, so the work done we have to find out. And Q, each coulomb, that means 1 coulomb of charge. Okay, so the W is equal to, by cross multiplication, it is 6 into 1, 6. And what is the unit of energy or work done? It is joule. So 6 joule is the answer. Questions from page number 209. These are the questions. Question number 1. On what factors does the resistance of a conductor depend? Resistance of a conductor depends on these things: temperature of the conductor, cross-sectional area of the conductor, length of the conductor, nature of the material of the conductor. So we can write the formula as R is equal to rho into L by A, where R is the resistance and rho is the resistivity, L is the length of the conductor and A is the area of cross section of the conductor. Okay, so here we can see resistance and length, it is directly proportional. When length increases, resistance also increases. Length decreases, resistance also decreases. But area of the cross section, it is inversely proportional to the resistance. Okay, so area increases, that means resistance decreases. When area decreases, resistance increases. Question number 2. Will current flow more easily through a thick wire or a thin wire of the same material when connected to the same source? Why? Okay. Here we are using the previous formula. R is equal to rho into L by A. Okay. And they gave like thick wire, thin wire. Okay. These are the options. Through which wire the current flow more easily. So thick wire means area it is more. Thin wire means area it is less. Okay, so resistance and area it is inversely proportional. So for thick wire, that means area more, resistance will be less. Okay, resistance less. Again, the current and resistance, it is inversely proportional according to the Ohm's law. So when the resistance is less, current flow will be more. Okay, when resistance less, current is more. Okay, so for the thick wire, current will flow more easily. Question number 3. Let the resistance of an electrical component remain constant while the potential difference across the two ends of the component decreases to half of its former value. What change will occur in the current through it? Okay, so here we are using the Ohm's law. V by I is equal to R. And voltage and current, it is always directly proportional. When voltage increases, current increases. When voltage decreases, current also it decreases. The ratio between these two will be a constant value, that is known as resistance. So here it is given like decreases to half of its former value. What the potential difference? So the potential difference now half. Okay, so the current also it will be half of the former value because both are directly proportional. Question number 4. Why are coils of electric toasters and electric ions made of an alloy rather than a pure metal? Here you can a table which shows the different resistivity values for different materials. Okay, so for metals are good conductors and which have very low resistivity value. But come to alloys, the resistivity value it seems to be increasing. Okay, so this high resistivity value is an important property of alloys and which we are using in electric toasters and this electric ions and all. Because high resistivity means there will be current flow will be decreased, and the other reason is at high temperature it do not oxidize. Alloys do not oxidize very easily. These metals always have a tendency to oxidize very soon, and oxidation means burning it will be happened. Okay, so that coil it will get burned. And the other thing that melting point of alloys it's very high comparing to metal. So it will take a lot of time to get melt this material. The melting point of an alloy is much higher than a pure metal because of its high resistivity. At high temperatures, alloys do not oxidize readily. Therefore, alloys are used in heating appliances such as electric toasters and electric irons. So, these are the three important points: high melting point, high resistivity, and do not oxidize. Questions from page number 213. Question number 1. Draw a schematic diagram of a circuit consisting of a battery of 3 cells 2 volt each, a 5 ohm resistor, an 8 ohm resistor and a 12 ohm resistor and a plug key all connected in series. Okay, so we have to draw a circuit diagram for the given data. 3 cells of 2 volt each. Okay, so 3 cells of 2 volt each means it should be 6 volt. Okay, and resistance it is connected in series. So first I am drawing the resistances. It is in series. We can draw like this. Okay, this is 5 ohm, this is 8 ohm, this is 12 ohm, and it should be connected to a 6 volt battery. Okay, so this is 6 volt and a plug key also connected. This is the circuit diagram, and current direction we can mention like positive to negative. Always current flows from positive to negative. Okay. Question number 2. Redraw the circuit of question 1, putting in an ammeter to measure the current through resistors and a voltmeter to measure the potential difference across the 12 ohm resistor. What would be the readings in the ammeter and the voltmeter? So we have to redraw the circuit diagram of question number 1, and we have to connect an ammeter and a voltmeter also to that old circuit diagram. And voltmeter, note the point, potential difference across the 12 ohm resistor. We have to draw the voltmeter across the 12 ohm resistor only. And finally we have to find the readings in the ammeter and voltmeter. So first we will draw the circuit diagram. So again it is in series, 5 ohm, 8 ohm and 12 ohm. Again the 6 volt battery and a key it is here. Okay, and now we should connect an ammeter and a voltmeter. Ammeter will be always in series with the resistance. Okay, and this voltmeter always it will be parallel with the resistance, and we have to draw across the 12 ohm only. Okay, so across the 12 ohm means it will be parallel to the 12 ohm resistor. This is the voltmeter. Okay, we can draw here also, that is not particular. Okay, and current it will be positive to negative. Okay, so this is the modified circuit diagram, and now we can find the readings in the ammeter. Ammeter reading, what it will be? The current through the resistor. Voltmeter reading means the voltage through the resistor. Okay, so we can use the Ohm's law here. V by I is equal to R. First we should find the current through the resistors. Okay, that means I is equal to V by R. V is 6 volt here, and the resistance will be the equivalent resistance of these three resistance. Okay, that means 5 plus 8 plus 12. Series connection, right? So R1 plus R2 plus R3. 6 by 25. By solving this, you will get 0.24 ampere. This is the current. And now we have to find the reading in the voltmeter. That means V is equal to I into R. Current we got like 0.24, and potential difference across each resistors will be different only. We have to find across 12 ohm. Okay, so into 12, and we'll get 2.88 volt. These are the readings. Now questions from page number 216. Question number 1. This is the question. So we have to find out the equivalent resistance in each case. First we will do the case A. Judge the equivalent resistance when the following are connected in parallel. Resistances are 1 ohm and 10 raised to 6 ohms. Okay. So what is the equivalent resistance in a parallel connection? That is 1 by R is equal to 1 by R1 plus 1 by R2. Okay. So here we can substitute 1 by 1 plus 1 by 10 raised to 6. You have to find the LCM here. So we'll get the LCM as 10 raised to 6 and it is like 10 raised to 6 plus 1. Okay, so 10 raised to 6 means what? 6 zeros we have to keep here. 1, 2, 3, 4, 5, 6 plus 1 by like this. Okay, but this is 1 by R. We have to find the R. So we should take the reciprocal of this. Then it will be by okay. So this means we can assume that okay, one thing you can divide this, otherwise this numerator it is less than denominator, and this is very close value, but numerator is just less than the denominator, then always the value it will be less than 1. Okay, this resistance value will be just less than 1 here. In the case of B, 3 resistance are there. Again 1 by R is equal to here 1 by R1 plus 1 by R2 plus 1 by R3. That means 1 by 1 plus 1 by 10 raised to 6 plus 1 by 10 raised to 3. Okay. So here the LCM it is 10 raised to 6. And it will be 10 raised to 6 plus 10 raised to 3 plus 1. Okay. So that means 6 zeros plus 10 raised to 3 means 1000. Okay. Plus 1 divided by okay. This is but 1 by R. We should find R. Okay. So take the reciprocal of this. By adding all these numbers we'll get yes 1 0 0 1 0 0 1. Okay, after adding these three numbers you will get the denominator like this. Okay, so again numerator is less than denominator, some close value it is, but again it is less than numerator, it is less than denominator. So we can assume that resistance again it is less than 1. Okay, here they asked like judge the equivalent resistance. We don't want to find the exact value. Okay, finding the exact value you should divide these numbers. Here just we can assume and we can judge that the equivalent resistance it is just less than 1 in both cases. Question number 2. An electric lamp of 100 ohm, a toaster of 50 ohm and a water filter of resistance 500 ohm are connected in parallel to a 220 volt source. What is the resistance of an electric ion connected to the same source that takes as much current as all three appliances, and what is the current through it? This is our question. Okay, so electric lamp of 100 ohm. Okay, lamp it is of 100 ohm, a toaster it is of 50 ohm, water filter it is of resistance 500 ohm, and all are connected in parallel. Okay, and voltage it is here 220. What is the resistance of an electric ion? That is our question. We have to find the resistance and the current. Okay, so in a parallel connection voltage it remains same, but the current it is changing for each resistances. So first we have to find the equivalent resistance here, and it is a parallel connection. So the equivalent resistance it is 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay. So what are the resistances here? 1 by 100 plus 1 by 50 plus 1 by 500. We have to find the LCM here. We'll get 500 as the LCM and the denominator as like this. Okay. So 16 by 500. This is 1 by R. So R is reciprocal of this number. So 500 by 16. This is the R. And we have to find the current. Current I is equal to V by R. Okay. V is 220. Okay. R is what here? 500 by 16. Okay. So we can rewrite it as 220 divided by 500 by 16. So it is 220 into 16 by 500. Okay. We'll get 7.04. And what is the unit of current? It is ampere. Questions from page number 218. These are the questions. Let us discuss one by one. Question number 1. Why does the cord of an electric heater not glow while the heating element does? Why it happens so? Okay, because the basic difference it is heating element, it is made up of alloy. Okay, and it will have high resistance and high melting point. So it is not allowing the current to pass that much. But the cord of an electric heater, it is made up of a good conductor or any good metal. Okay, so the current will pass through that. So electrical energy, it will be there in the case of cord. But in heating element, electrical energy, it is converting to heat energy, and it will get heated and it will start glowing. And this is the explanation in detail. An electric heater works on the principle of the heating effect of electric current. The heating element of an electric heater is made of an alloy, okay, which has a high resistance and high melting point. The heating element of the heater blocks the electric current and does not let it pass. Due to the high resistance, current is not passing through the heating element of the heater. So the heating element gets heated and glows due to the heat. Here the electrical energy, it is converting as the heat energy. But in the case of cord, the electric heater is a good conductor. Okay, cord is made up of any good metals. So it will conduct electricity and there will be the flow of current and electrical energy, it is produced here. So no heat energy it is there. That's why it's not get heated up and does not glow. So this is the reason why the cord doesn't glow while the heating element glows. Question number 2. Compute the heat generated while transferring 96,000 coulomb of charge in 1 hour through a potential difference of 50 volt. Okay, we have to find the amount of heat energy here. So the different formulas for finding the heat energy, it is V into I into T. Okay, this is the first formula, or we can use I square RT. Okay, or V square by R into T. Any of these formulas we can use to find the heat energy according to the data given here. So here it is given coulomb of charge and potential difference. Okay, so I it is not given. So I we can find out using the formula I is equal to Q by T. Okay, so the charges it is 96,000 by time in 1 hour. Okay, 1 hour means 3600 seconds. Always we should convert the hour to seconds. So this is the I here. So we can use this formula to find the heat energy here. 50 volt V I, it is 96,000 by 3600. Okay, into T is again 3600. So it will be cancelled, and after multiplying this we'll get 48. Yes, 5 zeros will get. Okay. So joule is the unit for heat energy. So we'll get like this, and again we can write in the standard form like 4.8 into 10 raised to 6 joule. Otherwise, if you write like this, that is also fine. Question number 3. An electric iron of resistance 20 ohm takes a current of 5 ampere. Calculate the heat developed in 30 seconds. So here resistance, current, time. Okay, so it is better to use this formula. H is equal to I square R into T. What is the I square here? 5 into 5. R it is 20. T it is 30. Okay, so after multiplying this, we'll get 15,000 joule will get, and again we can write it as 1.5 into 10 raised to 4 joule. Okay, any of the answer it is fine. Now we can discuss the questions of page number 220. These are the questions. First we will discuss the question number 1. What determines the rate at which energy is delivered by a current? Answer: electric power is the rate of consumption of electric energy by electric appliances. Hence, the rate at which energy is delivered by a current is the power of the appliances. Okay. For the case of any electrical appliances, the power means energy by time, or the work done by time. Energy and work done both are same only. Okay, so the common formula for power, it is energy per time. Electric power is the rate of consumption of electric energy. Rate of consumption means energy per time. Question number 2. An electric motor takes 5 ampere from a 220 volt line. Determine the power of the motor and the energy consumed in 2 hours. Okay, so we should find the power and energy. Both we have to find out here. So the basic formula we discussed already. Power is equal to energy by time. Okay, and what is the formula for power? Power is equal to product of voltage and current, V into I. This is the power. So 5 into 220. Okay, so this is the power 1100. And what is the unit for power? It is watt. So this is the power. Now we have to find the energy. So energy, it is power into time. Okay, that means V into I into T. V into I we already got as 1100. And what is the T here? 2 hours. 2 hours means 2 into 3600 seconds. Hours we always convert it as seconds. 1 hour means 3600. So 2 hours it is 2 into 3600. And after solving this, we'll get and what is the unit? Joule. And again we can write it as 7.92 into 10 raised to 6 joule. Okay, so this is the power and this is the energy consumed in 2 hours. I hope you understood the solutions what we discussed in this video. If you have any doubt, please comment in the comment box. Thank you for watching the video. Please like and share, and don't forget to subscribe the channel to get notification for new videos.